Welcome to Breakout Session B, Restoring Sight, the Bionic Eye, and Argus 2 with Dr. Bill Stell. Dr. Bill has donated his time for the past 3 decades to the Foundation Fighting Blindness as an expert scientific advisor. He is a professor of cell biology and anatomy, ophthalmology and surgery at the University of Calgary. He is also a member of the Hotchkiss Brain Institute. I'd like to introduce to you Dr. Bill Stell.
Thanks, Jamie, and thank you all for being here. Now, I took around a handout, which I think maybe everyone has, but if you don't, there's some more on a chair by the door. If you want to pick up extras at the end of the session, feel free. They're not being sold on the street corner, so nor am I. So feel free to take them when the session is over. And because you have a handout, and because I know some of you wouldn't be able to see a PowerPoint projection effectively anyway, the handout is it for graphic and printed material, and I'm not going to have any slides to accompany what I have to say. So the Bionic Eye has been in the news, and you may have already received some news from the Foundation Fighting Blindness because it is co-sponsoring a trial of the Argus 2 retinal electronic prosthesis, which is the correct thing to call it, and the first results are starting to come out. But what is the Bionic Eye? Well, it's not, first of all, it's not really an eye. There is no such thing today as an eye transplant. And very likely, if ever there is such a thing, it's going to be a long, long time before a whole eye can be transplanted in to replace one that's defective. What we do have is a replacement for rods and cones that are lost. These are the main photoreceptors with which you have everyday vision. And the Argus 2 and other retinal electronic prostheses are replacements for lost rods and cones. So this is a little bit like, you can think of your rods and cones as sort of the cell phone of the eye. They respond to light. Your cell phone responds to your voice. And if the cell phone dies, well, you might be able to recharge it. So in other sessions in today, we are talking about some recent and prospective developments to save or restore the function of rods and cones that have lost it somehow. But if they die, it's like the cell phone really dying, and you've got to get another one or find some other way to get your message to the intended recipient. And so the function of an electronic retinal prosthesis is to do that, to act like a replacement cell phone that can respond to light and that can get a message somehow to the brain so that we can perceive it. So the Argus 2 and others like it work only if the rest of the retina, at least the output part of the retina, is still alive and working. So if the retina were completely destroyed, the prostheses that we're talking about today would not be useful or appropriate. There are other kinds of prostheses that are mostly in the thinking and talking stage that have been tested in the past and found to be possibly useful, that would take a video image and transform it into an electrical stimulus that goes directly to the brain, so bypassing completely the eye, the retina, the optic nerve. But such things are not currently available, and as far as I know, they're not currently being tested in clinical trials So what I have to say today isn't going to deal with those kinds of prostheses at all. So what is this prosthetic device? Well, most of the prosthetic devices that are being tested and intended for use in human subjects are electronic things that use a video camera to capture images, that transform that image in some way to a small set of spots, so that a spot out there, such as you would see if your vision is normal, is encoded in a little computer and made to make an electrical stimulus in the retina at a place that corresponds to that spot out there. So that if spots are here, here, and here, left, middle, and right of me, then I would see them. I would see spots of light generated by the prosthesis in the right places in the world out there. So there's a video camera. There's a connection from the camera to some kind of a little computer that is outside your body. That computer sends a message to a transmitting device. And in the case of the Argus II, there's a wireless transmission between a transmitting device outside the body, outside the eye, outside the head, that's shown as the round thing in the picture of the person wearing the device. I think it's on the back of your handout sheet. And then underneath the skin and in the orbit, attached to the side of the eye, in the case of the Argus device, is a receiver that gets that. So it's just like Wi-Fi, in effect. Or it's like if some of you might actually have a cochlear implant because you have some hearing loss, or you might know people who have them. So the principle is very much the same. And if you know somebody with a cochlear implant, you've seen that they put a little thingy on their skull, and that's there to transmit through the skull to a receiver that's close to the inner ear. So the same thing with the Argus device, and in the diagram on the right-hand side, on the second page of your handout, you'll see there's a disc that looks like a big piece of silver candy or something that's attached to the outside of the eyeball. And then a cable goes from that, carrying all of the messages for the whole device. So with the Argus II, that's a 6x10 rectangular array, so 60 electrodes. So there's a cable with 60 tiny filament-like wires that goes from the receiver on the outside of the eye to the chip that is implanted surgically, stuck against the front of the retina. And from that project tiny electrodes, tiny pinpoints. How tiny? On the order of 1/100th the thickness of a dime. That's pretty small. That's about 10 micrometers. And so each one of those tiny electrodes is connected, if you trace it backwards now, is connected to a point in the video camera that corresponds to a certain point out there in the visual world. So when light shows up in that spot, it's transformed and transmitted and made into an electrical stimulus that stimulates in that part of the retina. Now, what happens from then on? The cells that sit at the inner surface of the retina, which are called the retinal ganglion cells, they're the ones that receive through a relay normally the signals from rods and cones. They're not getting those signals now. Now they're getting this electrical stimulus instead. And it's their nerve fibers that run along the front surface of the retina and to the optic nerve and go to the brain. So as long as those are still there, as long as the retinal ganglion cells are still there and their nerve fibers still extend through the optic nerve to the brain, then they can be stimulated electrically, and that will give some kind of impression of vision. So in effect, this is a detour around damage. And it's kind of like, okay, if your cell phone is dead, how are you going to get the message to the person you want to contact? Well, you might find an old, slow, dumb landline phone, and you could get through with that, or you might have to actually walk there yourself. However you do it, it's not going to be as quick or as precise or as powerful as the smartphone that you started with. Well, that unfortunately is also the case here with the retinal prostheses that we have today, specifically the Argus 2, and with alternative devices that are being developed and tested at a number of places in the world. So, so what can the Argus 2 and other electronic prostheses do? Well, they can detect light. They can get the brain to get some impression of light. But the impression of light that they get, for technical reasons that I won't go into unless someone wants to nab me afterwards and get those details, the impressions are called phosphenes, and they're really just shapeless blobs of shimmering light, more like the northern lights than the sun, say. Well, okay, this can still be useful, can't it? It can help you see something that is relatively bright against a background that's not nearly so bright. It can help you to detect that something is kind of around there rather than around there, and that it's brighter than the thing over there. So, unfortunately, this is a very rudimentary kind of visual sense. And it is in no way a substitute for the vision that the retina was originally capable of. It's in no sense a substitute for normal vision. But people who have the Argus 2, which has been the best tested, do have the ability to navigate a little bit better using some visual signs, using these contrasting, these impressions of contrasting light and dark areas. So to find your way into a lighted doorway from a darker room, for example. So they would be another extension of your sensory faculties. In its way, not terribly different from a cane, except being able to extend the sensing to some distance beyond what the cane can do. I think, so these devices, all of them, are really intended as something for someone who has no sight at all. If you have any residual vision, you would not gain anything above that by having any of the bionic eyes that are available now. And while it's difficult to tell what unexpected advances can be made in the future, I think that it's unlikely that anything of this sort, that any kind of chip on the retina is going to come close to reproducing normal vision. For example, any electronic device, even a very advanced, technologically advanced, and very expensive commercial TV system for videoing sports events outdoors and conventions indoors and so on. Such things are not very sensitive, so when the light gets dim, they get very noisy and they get snowy, and you can't really see anything anymore. One thing that our retinas are very good at is suppressing the background noise in a very dimly lit environment so that we really can see usefully. And at the other end, electronic devices get saturated by too much light. Even the fancy ones that are used for outdoor, if a video camera pans from a dark area to a light area, there's at least a brief moment of being totally flooded with light before the camera readjusts to the new light level. Well, our normal retinas do this without our thinking about it, without our having to try at all. They do it automatically and very quickly. So it's going to be a while before artificial devices will be able to replicate that. So I think that the Argus II and similar devices are wonderful inventions. We can be grateful that they're there for the relatively small number of people who can benefit from them, and that is those people who have really no vision left at all and can use them as another accessory, mainly useful for getting around. There are limited possibilities, I think, for making them much better in the future. And so my pitch is that we want to support the further development and clinical trials of the Argus II and other devices. But in the long run, what we really hope is to replace visual function in other ways. For example, to replace the lost rods and cones with new ones derived from the cells grown in tissue culture and induced to become rods and cones. And I can tell you with pleasure and confidence that great strides are being made in this area, and some of the best scientists in the world are working in this area in Canada and are being supported by the Foundation Fighting Blindness. Another area of great interest and potential power is to prevent the vision loss in the first place. And for AMD specifically, you know that it's only been about 10 years that we realized that certain gene changes predispose people to getting AMD. We didn't know that before 10 years ago. So the development of drug therapies to slow down or prevent the progression of AMD is really in its infancy, and I think I can confidently predict that in the next 5 or 10 or certainly 20 years, there will be very effective non-surgical take a pill kind of therapies to stop AMD in its tracks or to prevent it even occurring. And finally, and you'll see this on the front of your handout sheets, there are two dotted line things at 5A and 5B, a special application of gene therapy, which some of you at least were lucky to hear Dr. McDonald talking about this morning, is to introduce into the cells that remain in the retina after the rods and cones die, to introduce light-sensitive molecules. So the relay cells, the bipolar cells that represent the activity of rods and cones, have already been, this has already been done in the laboratory in experimental animals, in mice, to make the relay cells, the bipolar cells, or the ganglion cells themselves light sensitive. And there are tremendous potentials for doing that. The main drawback at the moment being that we can't put into them yet, with the tools that we have available, all of the machinery that makes a rod or a cone work. But I think it's only a matter of time, not a matter of any intrinsic limitation of what can be done, it's only a matter of time before that can be done too. So, to wrap it up, there is excellent potential for those who have no sight at all to gain some advantage by having a retinal chip. And if you are yourself, or if you know somebody who has no vision at all, there may still be opportunities to get into the clinical trial that's being conducted in Toronto. Don't necessarily avoid it because it's in Toronto. It's a great opportunity for us in Canada and even in Calgary to take advantage of this. But in the long term, much is to be done to develop these other kinds of therapies that are going to be much more powerful, that are going to definitively prevent vision loss or restore proper, complete normal vision, even if it has been lost. So that's the end of my talk, and I think you have most of what I've said in one form or another is on the handout, and I'll be happy to answer any of your questions. Question over there. Yeah, put up your hand if you have a question, and someone will come around with the microphone.
Thank you.
I might have missed it, but do you have a context of how many Argus 2 have been installed, and then the other, I guess, the Retina Implant AG and the Bionic Vision Australia? Do you have an order of magnitude?
Yeah, it's small. It's small.
So 10?
The mandate here in Canada is to install between 5 and 10. It has been dozens, I don't know exactly the number, in the US, and something similar to that, I think, in Europe. And humanitarian approval has been given for use of those of the Argus 2 in both Europe and the US. And also the German device has been approved for use in Germany, in Europe more generally. And what we're aiming towards is getting that approval here. So in probably on the order of 100 patients at least have been treated with the Argus 2. There have been, so far as I know, no serious incidents of any kind with any of them. And the German device, I recall hearing a report by one of the inventors had been successfully installed in 5 or 10 patients. This was about 5 years ago. And again, no serious incidents were uncovered. And in 1 or 2 cases, the devices had been removed after a couple of years. So that answers a question that I heard earlier. If a better treatment comes along, can you get rid of the device and give the better treatment? Absolutely.
So given that the brain is already so good at pattern recognition, wouldn't it possibly be easier just to put in, I'd like to call it standard sort of color-sensitive photovoltaic sort of cells in? So light hits a cell, it sends a very specific wavelength. You send that down either the optic nerve or maybe replace that with your own wiring of some type. And then let the brain figure out what that all looks like, even though there'd be like of course there'd be a learning curve because the signal would be different, but there's still patterns within that. So would that be possible, or is there issues with the brain not accepting those signals?
Okay, that's a very interesting question. I'm going to divide it into 2. One is that, yes, the brain is very adept at recognizing kinds of input that it hasn't been exposed to before. And that is, in fact, a necessary part of becoming a user of the Argus 2. So once the device has been installed, the new users have to spend many hours, tens of hours, and training so that they can use this kind of sensation, which is not really real vision, but to use it as vision. The second question, whether we can use a chip that somehow signals color or other attributes, that's probably the most difficult and maybe technically impossible things to do, because the output of the retina consists of many parallel channels that represent different features of what we see. So there's one for red, there's one for green, there's one for blue, there's one that for light that's turning on and staying on, there's one for light that's turning off and staying off, and so on. There are about 15 or 20 different kinds of things that are signaled in the optic nerve. So one of the reasons why the output of the Argus device is seen as diffuse light flashes is that all of those things are being stimulated at once. And there's no way that the brain can sort out individual attributes from that.
That's why I had asked that, because I noticed you said send it to a visual processing unit instead of, whereas what I'm saying, instead of sending it to a visual processing unit to what looks like convert it into something that's similar to what the brain already is, just send the raw data and all its component little wavelengths and parts and let it figure it out.
Yeah, but you know, in fact, the brain doesn't work that way, and it's set up with, it's set up kind of the way human language production and interpretation is set up. So you've got English speakers who can speak and understand English. You've got Hungarian speakers who can speak and understand Hungarian. And if they both speak at once, then it's only the English that the English understander will understand. So when we bombard the brain with all of these signals from an electronic prosthesis, it's hearing all those languages at once, and every cell in the brain that receives visual input is going to say, yes, I'm seeing red, or yes, I'm seeing green, or yes, I'm seeing light turning on, or yes, I'm seeing light turning off. And that doesn't make for a very sensible thing. You know, it's a sort of babel of visual language.
Which is the learning thing.
No, it's not. No. Yeah, unlike languages where people can learn the other language, there are specific codes that this line means this, that line means that. Yeah. Sorry, I wish it could be otherwise, but I don't think that is the way things are going to work. Back there?
Yeah, the question that I have is this device good for people who have something like tunnel vision, is where you can see around the edges of your eye, but the pupil of your eye is all gone black, like dark? Is this their device any good for that?
Okay, I think your question is if you have central vision loss from macular degeneration of one kind or another, could a device like this be implanted in the center and give you back something in the central region that's not seeing? Is that your question? Yes, it certainly could, but you know, the acuity provided by the Argus 2 is way below what's legally blind. So I think that this would not even restore the capability of vision that you have from the peripheral part of the retina that's unaffected by the macular degeneration. That might be juiced up a little bit, and as a matter of fact, the German device, which is quite different in conception, first of all, it's placed subretinally, so that's number 3 on your handout. That provides much more point-by-point stimulation, so it's capable, theoretically, in principle, of better acuity. Some people who've received the German device can read large letters, very large letters, but they can read them. Well, we can make letters larger with optical devices. That's no trick. But still, I think optical aids, special spectacles, implanted lenses that magnify. There are a number of other ways of improving what you can get out of the residual peripheral vision. And I don't honestly think that Argus 2, anyway, would be very helpful. I think if you've still got some vision, it's probably better than what you would get from this device. This is really something for people who don't have anything.
Yeah, I'd just like to go back with your future thoughts of that there'll be a pill in 10 to 20 years, and that'll help macular degeneration. In the other talks I've seen that they said there is a pill out or in research or not saleable to the public yet. I wonder if that's available anywhere else in the world.
No, I don't think that a pill that would specifically target the problems or the defects that are responsible for AMD. I don't think that anything of that sort is available anywhere, so far as I know. Dr. Karani or Dr. Williams, would you happen to, is there a pill that is specific for AMD?
Not yet.
No. There are nutritional supplements.
Thank you.
That are somewhat helpful, but drugs are under development. One of the things that we've learned now in the past 10 years about AMD is that the genetic predisposition is due to a defect in the immune system. So if it's in the immune system, then potentially there are many ways that a drug that we could take orally could be used to combat it. And I know lots of people who are working on that very actively now. I think that's something that could easily come along in 5 or 10 years and could offer some relief for those who already have AMD and could prevent the progression of many when they just are starting up.
Excuse me. You have to have a contrasting light to see this? Or what would you see if you're out in bright sunlight? Or what would you visualize, I should say?
Well, without fairly strong contrast between dark and light areas, these devices will not produce anything useful visually. So they would be pretty much blasted by bright sunlight, just the way it is for you. If when your vision was normal, if you walked out from a dark room to a brightly lit room or outdoors, you'd be dazzled for a while. And these devices will be dazzling when the light's very bright.
Thank you. How much does installation of this device, how much does it cost these days?
Well, since it's not readily available here, I don't know. I don't actually know how much is being charged for it in the U.S. or Europe. But given that, no. And I think you can, to recapture the costs that have gone into developing these things, oh my goodness, it would be hundreds of thousands of dollars each. In fact, the tests that are being done in Toronto are costing on the order of $100,000 per trial patient. The patients aren't having to pay. The Foundation Fighting Blindness is paying, and the company is paying. But I don't think we can really fathom at this point how much a device is going to cost when it becomes available to anyone who qualifies in Canada.
I have collarbona eyes. I don't know if you know what that is.
Sorry, you have coloboma?
Coloboma?
Yes, I
yeah.
do.
So I do have color and light and dark, but very minor. Can this work for me?
I think not.
I think not.
No, I think if you can see well enough to make your way around.
Well, the one eye is okay for now.
Mm-hmm.
The other eye, I have just light and dark shades. I couldn't tell you were there,
Well,
but I have that, so there must be some optic nerve somewhere there.
Right. Yeah,
Can-
I think if you have a vision of spots, and if the spots are related to what's out there visually,
Okay.
if you see it bright because there's actually something bright out there where you're looking, and dark where you're
Yeah.
looking dark, then that would be rather comparable to what this device will provide.
Okay.
And in that case, it might be useful to inquire of, through the FFB, inquire of the people who are doing the testing in Toronto, to use their training methods to help you make better use of the vision that you have.
Okay, it's very minor. Like,
No. I'm sure that a number of you in this room who have AMD have some useful vision, but it's kind of blotchy, and you might see vague forms in some part of your visual
Yes,
field.
yes.
And I think training to use those things that you have, which is exactly what people do who get the Argus 2, might be very helpful to you.
okay, thank you.
Sure. And you can inquire of the visual rehab. There's a visual rehab center of some kind at the Rocky View, isn't there, doctors? Yeah. I would ask them what they can do to train you to better use what you have, if you haven't done that already.
I was told that, it's a lot.
No, you've been told, yeah, there's nothing we can do for it. You wouldn't be here, any of you, if you believed that. So, so what we all believe here is that there is nothing that you have that nothing can be done about. It's just a matter of when, and how good will it be, and how much will it cost. And the business of the Foundation Fighting Blindness is to make those things happen. So please support the foundation in any way that you can. Thank you very much.